All right, so this section we're looking at surface area of pyramids and cones. And again, you may have done this a little bit before, but basically, if you think about what the net looks like, that's going to help you, and you will have a formula sheet as well. Let me just pull up what the back page of your workbook looks like. So charts and formulas, there's some conversions for metric, imperial, and then take a look here. There's surface area for a prism, so 2 times the base area plus the lateral area. However you calculate that depends on what the base is, right? How many sides you'll have in the lateral area. But then they're specific here for a rectangular prism, right? So this is sort of the old way in 3.2. We did it where you could do 2 times the base, so this method, and then the lateral area, we found the perimeter of the base and multiplied it by the height, and that would take care of these 2 terms here. Surface area of a cube, all of those sides are squares, so that's why it's just 6 times the area of the square. Then cylinder, so here, this is sort of the more common one. Notice how it says or. So 2 pi r squared, that's the 2 circles, plus the rectangle that folds around, right? And that's the circumference of the circle times the height. This is basically factored out. We don't use that often, so I kind of ignore that for now. Surface area of a pyramid, so that's what we're looking at in this unit. Base area, because there's just one base, and then half of the perimeter of the base times the slant height. Okay, and that's sort of the fast way, like we talked about with prisms. And then cone is the area of the base, pi r squared, pi r squared. And then the face, it's actually a sector of a circle. And so that's really pi r s, where s is the slant height. So same kind of slant height here. And the surface area for a sphere is 4 pi r squared. Okay. Another version, pi times diameter squared, but we tend to not use that as much. Then it gets into volumes and then other concepts in the course. So use that back page if you need to. Okay, so looking at the try these, it says which triangle has a greater area? How do you know? So without calculating, right? We know the area of a triangle. So let me just write the area down. The formula is a half base times height. Sometimes you might see it as base times height divided by 2. Means the same thing. But the base and the height have to meet at 90 degrees. So here, this is a 90-degree triangle. So this is the base, this is the height, and you multiply by half. Here, different shape, but here's the base, here's the height, because they meet at the 90 degrees. And so it's a half of each. So notice how the heights are the same, but the bases are different, and this one's smaller. So that means this triangle 1 has the largest area. Largest area as base is larger and heights are the same. Okay. All right, so now we'll get into some pyramids. So on canoe trips, Benoit packs 2 pieces of canvas to make this pyramid tent. 1 piece is for the walls, 1 is for the square floor. What is the least amount of canvas for the tent? Okay, so there's the floor. There are the 4 triangles. So that's his second piece of canvas. He's actually made it. So those are triangles where you can put the bars in to hold it up, and then there's a space there. So that when you fold those together, it has what we call an apex. That's the point at the top. Okay, the slant height of the pyramid is the distance from the top of the pyramid to the center of any side. So that's basically where that shadow of that bar is. Okay, that's the slant height for a pyramid. It's the same as this here. Okay, that dotted line. Okay, so use this formula to determine the total area of the walls. So the lateral area, and then that's kind of like what we were doing for the prism. We want to find the perimeter of the base, okay? And then think about that. That's all of, these are all triangles. So the area of a triangle is 1/2 base times height. So if we do find this perimeter, well, it's really this perimeter, these four sides, then it's like we're calculating all the triangles together. So that side, that side, that side, that side, and then multiply by the height and by half. Okay, so perimeter, what does it say over here? So the perimeter it's a square. It's 10 by 10, which means the perimeter is 40. Okay, so perimeter of the base, I'm just going to put it up here, is 40 because it's 4 times 10, and the slant height is 8. So now we'll put it in, I guess, yeah, put it in there. Maybe I'll go back to this and put 4 times 10. So you see where that comes from. Okay, so then half of that's 20 times 8, so 160 square feet. So total surface area of the tent, including the floor, well, remember there's just one square floor, and so that is 10 by 10, which is 100, plus the 160 is 260. So the least amount of canvas is 260 square feet. Okay, let's look at the reflecting. The area of a triangle is 1/2 base times height. Why does it make sense that for the formula for the lateral area of a pyramid is 1/2 times the perimeter of the base slant height? Well, that's what I talked about before, right? Because we're just splitting this. If we did it the long way, we would have 1/2 times 10 times 8 plus 1/2 times 10 times 8. We'd have 4 of those, right? And we'd have it again and again and again. So we'd have 4 times 1/2 times 10 times 8. And so really what we're doing is just multiplying the 10 by 4 rather than the 1/2. Okay. Next example is a cone. So a red cedar statue of a trout stands outside the Chamber of Commerce in Kamloops, British Columbia. The stand is a metal cone. What area of metal is needed for the stand and its hidden base? Okay, so we are doing the base as well, even though it's hidden. So here, take a look. This is the base. It's a complete circle. And then this is the face. It's part of a bigger circle in this case. And so you might want to try this. Draw a circle, cut out a piece of pie, basically, and then fold to get these to meet each other and tape them up. And then you'll have a cone. Okay, so and always think of a cone as an ice cream cone. That's the most common one we use. So this outside part, that's what your actual cone is. And this base at the top, you might think more of, not an ice cream cone, if you've ever had a drumstick, that's what they call it. You buy it at the grocery store. It doesn't have the ice cream coming on top. It's squished in, and then the wrapping is a circle at the top that you take off. I think it's chocolate colored. It's really good. So what is the area of the circular base of the cone? So pi times, we need the radius is 1.6. Okay, so we'll get our calculator out. Pi times 1.6 squared is, and again, keep a few decimal places, 8.0425. 1.0425. Okay, then we'll have to flip to the next page. Use the formula to calculate the lateral area of the cone. So lateral area is pi rs, where r is the radius of the circular base and s is the slant height. So pi times the radius was 1.6. I've got to go back and look. I can't remember. The slant height is on the edge there. It's 3, or 3.0. And so we'll get our calculator out. Pi times 1.6 times 3, 15.0796. 15.0796. What is the total surface area of the cone? And so we add them together, right? So this will just copy out here. I'm going to have to go back and look at the previous. That was 8.0425. 8.0425. So on my calculator, I have the last calculation. On my calculator, I can add and then go up and copy it. But if not, you just copy out those 4 decimal places afterwards. That's accurate enough. And because we're going to round to the probably nearest tenth. So 23.1, I'll go to 4 decimal places, 1221. And then basically that's, if I round to the nearest whole number, it's 23 meters squared. Okay. All right, and then traffic cones. I've seen these a lot. You use them in gym class. These ones are bigger, probably than the ones you use in gym class, but same deal. Says Amrita's company rents traffic cones. One cone is 28 inches tall and has a base radius of 7 inches. What is the lateral surface area? And so we are going to assume that this is going up to a point. A lot of them do. This picture doesn't seem to be, but we'll assume that it's going up to a point. So it says it's 28 inches tall. So you have to be careful here. So again, in this course, we're doing like a few little variations. Oh, that's not very, let me try that again. I'm just going to fix this. Okay, so I'm going to go up better. Actually, I could use a line here, and I'll use a dotted. And I'll just, oops, not that. Line. Dotted. There we go. Okay, and so it meets the base there, and this is 28 inches tall, but we need the slant height if we're finding lateral surface area. So that's where we've got a Pythagorean theorem that we've got to use. So coming out here, this is 90, that's 28. This is half of the well, it's the radius, which we weren't given diameter, so that's 7. So now we need to find the hypotenuse, okay? And that, in this, is called the slant height. And actually, what I do for slant height is I often do a written S, just so it doesn't look like a 5. So that slant height squared is equal to 7 squared plus 28 squared. So in your calculator, 7 squared plus 28 squared is 833. Okay, and then we're going to square root that. So if it's already in your calculator, you can usually, scientific calculator, you can just press square root and it will do it. In mine, I have to copy it out. And so now it's 28.8617, 28.8617. Okay, I'm keeping a few decimal places because I'm working backwards, not done yet. So what is the lateral surface area? It's, remember, pi rs, so pi times the radius times that slant height. Notice how it's not a whole lot bigger than 28, but it is bigger because it's the hypotenuse, so it should be. Okay, so now in our calculator, you take pi times 7 times. Now, if you can copy out that lateral slant height, or you can copy out what we had to 4 decimal places. And what do you get? 634.7028. 634.7028. And so that's approximately, if I round to the nearest whole number, 635 square inches. Okay? So just some slight variations. You've been doing some surface area over the last few years, but just adding a little bit extra to it. Maybe you have to work backwards to get the slant height. Maybe you have to work backwards to get an area of one of the sides, that kind of thing. All right, so now do the practice. And then after that, you're going to do the mid-chapter review.